Okay, let's talk about what a spatial join is. Thinking back to earlier chapters, we talked about attribute joins where you had a data set and a table or two different data sets, but they had this common field where you could identify the same code in each data set so that you could align or join those based on that. Spatial joins work in a somewhat similar fashion. You have two data sets and it combines them together. The big difference is it doesn't use some field like that. It does all this based on spatial location, the physical position of the data sets in real space. Spatial join conditions join two tables based on a common spatial relationship. So instead of a common field, it's a common relationship. Things like one feature inside another or one feature closest to another. The first type of join we can talk about here is a distance spatial join. A distance spatial join appends records based on which source feature is closest to which destination. So in this example, you have this source like airports, and you have another layer, cities, and we're going to do this distance spatial join, and what we're trying to do is to attach the airport to the city, okay? And it's just a simple distance thing where the airport that's closest to each city becomes that city's airport. The inside join is even simpler. It appends the records of the source feature, geology, to that of the destination feature, wells, that fall inside. So here we have these various wells, and then we have this geology. What we want to do is take that geology information and add it to the wells. So the spatial join looks at each well and says, what geology am I inside? That is the geology information that is then attached to that well. This brings up the topic of cardinality, and cardinality has a lot of different meanings in some context. Cardinality is north, south, east, and west. It has to do with direction. But inside the middle of GIS, that's not what cardinality means. Cardinality has to do with what and how you're joining things. Specifically, when we talk about cardinality, we're talking about whether we're joining one thing to one thing, or many things to one thing, or one thing to many things, or many things to many things. Now, that's a little bit hard to wrap your head around to start with, so let's walk through it a bit, and hopefully it'll make more sense. If you switch the destinations that we talked about earlier to airports, and the source to the city, so basically just do the join, the spatial join in the other direction, each airport serves many cities, and the cardinality is now one to many. Okay, that's one airport gets attached to many cities, or is it many cities get attached to one airport? Well, I don't particularly like the way that they use the destination and source thing here, but we'll just be as straightforward and simple as we can. We're taking the airports and we're joining the cities. But for each airport, that airport could be the closest airport to a lot of cities. So it's not a single city. Okay? Now, the rules of joining says you've only got one spot, for each data entry. And so whatever you're putting in has to go in that one row. If you're adding more than one thing, like if you look up there in the map, each of these airports, you see the colored dots around it. Those dots are the cities that relate to each airport. So clearly, some of these cities, um, there are a lot of them for the airport. So what do you do? Well, you have to summarize the information because you only get one line. So in this instance, um, we get a count. The count tells us how many cities it is, and then it summarizes the various fields that was in the data. And so if you look at the data for the cities above, you had the city name and the population. Once we summarize it, we have a count, which is the number of cities and the sum population of all those cities. So for Mulholland Sweet Field, there's 31 cities that's the closest airport, and the sum total of their population is 204,048 people. Airports to cities is a one to many. Many city records become a single record containing some statistics which can then be joined to the airport. So we have the count and we have the sum of the population. We could take that, and do other things with it, but that's the gist of what and how this works. You could also then, for example, use a graduated symbol size for the airports. And the bigger that sum population, the bigger the symbol you use for the airports, indicating the population that is closest to those airports. Summarized joins are used to handle these one-to-many relationships. They determine the spatial relationship, summarize the source features that match each destination feature, and then append the summarized statistics record to the destination feature. Spatial join cardinality. The rules of joining applies to spatial joins as well. Simple joins are simply one-to-one or many-to-one. Summarized are one-to-many or many-to-many. In order for this to work, you got to think back to what is source and what's destination. And it seems a little backwards from the way that I tend to think about it. But for a simple join, many to one means that you have a lot of these things and they're all joined by the one thing. That's the many to the one. It's actually, in my mind, it's the one thing being joined to the many. I look at it the opposite direction. Makes more sense to me that way. But we'll stick with what they're saying because that's what's in the textbook, and we don't want to confuse you. Simple spatial join, one-to-one or many-to-one. There's no ambiguity in assigning the fields. It is straightforward. For every field, every data input, every row in that table, there's only one bit of line there that's attached to it from the other data set. Users can optionally choose a statistic to calculate. For example, sum, or you could calculate other things. Instead of sum, you could get mean or median, or you could have it calculate all of them. The destination table is counties. The source table here is schools, and the output table gives the total schools located in each county. The count field is generated automatically. That tells you how many schools there were in the county, and then all the other data would be summarized. So it could be sum or median or minimum or maximum or any number of values, but those would come from that group of schools in said county. Point-to-point joins are kind of interesting. These are distance only. They can be simple or they can be summarized. It really just depends on what and how the question you're asking. Which attraction is closest to each hotel? In which case, you look at each hotel. It looks at a distance field to find out which of the attractions, or in this case the stars, is closest to it. And so it's a one-to-one, simple, not obtuse kind of a relationship. Now, if you asked how many attractions are closer to one hotel than another, that's an entirely different thing, because what you're doing now is each hotel is closer to one of these three, or each of these attractions is closer to one of these three hotels. And so in this case, they're color-coded based on which one they're closest to. But if we're looking at that from the hotel standpoint, let's look at the one on the left. There's 1, 2, 3, 4, 5, 6, 7. There's 8 of those purple stars. Those 8 purple star attractions are closest to that hotel. And so if we were to join all that together, it has to be summarized, because you can't join 8 things to one thing. You have to condense it and summarize it so that you're ultimately joining one thing to one thing. Types of spatial joins. This little diagram is kind of describes it all. Joins are either simple or they're summarized. They're either inside or they're distance. If something's inside, it's is this in that. If it's simple, it's one thing inside of one thing. If it's summarized, it's multiple things inside of one thing. If it's a distance join, it's all about how close or how far am I from something. If it's simple, it's from this one thing, what's the closest, nearest, or farthest, or what have you, other thing. But it's still one-to-one. If it's summarized, it's how many of these things are closest, farthest, whatever the distance thing is, to the other thing. And so that it's multiple things, which means it has to be summarized. Feature geometry in spatial joins is actually pretty important because when you change your feature geometry, for example, projecting data versus unprojected data, never ever ever do any kind of spatial analysis on unprojected data. Enough said. Let's take a look at the next slide. Distance joins, points to polygons, join each county to the hospital that's nearest. Each county feature gets the name of the closest hospital, and all that kind of stuff makes perfectly good sense. Polygon distances. This is important. If you're measuring distances for polygons, the centroid of the polygon is used. The centroid is this crazy calculation where it looks at that polygon and tries to find the center of it. Here's the thing. Some polygons are very irregularly shaped, and in some instances, that means the centroid isn't actually even inside the polygon. But you can make it be inside the polygon, but then it's not really the true centroid. Distance points to lines. In this example, we evaluate the impacts of streams and septic systems. And so the stream is the destination. Each point represents one or more septics. And so we want to know the number of septic points closest to each stream segment and then summarize the totals. Now there's a big assumption here that's really completely invalid. Just because it's close to it doesn't mean it drains into it or even has the potential to drain into it, because it may be closer to one than the other, but the change in elevation, the slope, and lay of the land may not even run that drainage towards that section of the stream. But still, you can see here how this would work, where for each segment of the stream, it identifies, well, for each data point is identified to its closest stream segment. Then each segment looks at the sum total of all the data points, the septic systems that's closest to it, and then it calculates summarized data based on that for each segment. As far as feature types, every join involves two geometry types: points to points, polygons to lines, lines to points, etc. Each combination offers two possible types. Usually it's a simple one and a summarized one. Now in the next example, this is one that irritates me. They're going to break with their traditional destination on the right, and they do this to match some kind of thing in ArcGIS join menu. The destination table is shown in boldface. So points to lines, lines to points, polygons to points. You see the simple, the distance, the summarized, and all that kind of stuff, and then it gives you some examples. You can go over this if you're confused or after you've spent some time listening to the lecture, reading the chapter, doing the exercises. It's always a good time to come back, particularly for a slide like this, and go, oh yeah, now I understand. So let's look at points to points. Destinations, hospitals, simple distance. Find the source feature that's closest to the destination, hospitals to towns. Summarized, all the towns that are closest to each hospital. Makes sense. Polygons to points. Simple distance, find the county that's closest to each hospital and give the hospital the county attributes. One county to one hospital, no big deal. What about a simple inside join? Find the county that each hospital is inside and give it that attribute. Polygons to lines, simple distance. Find the park that's closest to each road, give the road the park attributes. Summarized inside, interstate travels across a bunch of counties. total population of all the counties that the interstate crosses are summarized for that interstate, giving you an idea of the population near the highway. Some things just don't make sense, and will give you answers that you really can't use for anything. Finding the closest county to each river, what the hell does that even mean? Who knows? Find the county a river is inside does, but what does that actually mean? Some rivers cross county lines, and that's one of the problems with spatial joins. You see, it can't really address that aspect. That's where you need overlay functions, but that's a lecture for another day. Polygons to polygons, simple to inside. Urban areas are given the attributes of the counties where the urban areas are located. Summarized, each county gets the summarized attributes of all of its urban areas. Why would you want to do something like that? What if you got a really big county? It's got several really large towns. You could summarize the populations for the towns and join it to the county so that you would have the county total and the summarized town total. So now you could calculate up a percent of urban, the percent population that's urban, and that might give you an idea of whether it's more of an urban county or a rural county. Just more examples. I'm not going to sit here and keep reading all these off, make this video even longer and make it even harder to render and post and do all that. You guys can take your time and sit there and read through stuff like this. Textbook gives wonderful examples. Mary Beth Price has an outstanding textbook she's put together, and the examples, the tutorials, the videos that they have that come with the tutorials to show you things when you get stuck, it's just a tremendous learning resource, and I encourage you at every opportunity to use it to the fullest. So let's look at some more options. These examples are a few of the possible combinations. The rest they show in the text. It seems complicated. Don't worry. Usually it all comes down to is inside or outside. Is it simple or summarized? Coordinate systems and distance joins. Why does this matter? Well, look at the coordinate systems, and if it's in a GCS, how will your distances be calculated? Hint, it's angular degrees. What does a distance of 0.474633 degrees mean? Answer, absolutely nothing. That's why we don't do any analysis on a GCS. You should project that data into a projected coordinate system, and then the distance functions that you need to do some of these spatial joins would have meaning, because it would be in feet or meters or aardvarks or something, but not in angular degrees. Distance join units. The source data were in a GCS. You get decimal degrees, which are useless for this kind of stuff. Decimal degrees cannot easily be converted to miles or kilometers because the conversion factor changes with latitude. If you think about the way the lines on the globe work, the closer you get to the poles, the closer the up and down lines get to one another. This means that the calculations for angular degrees into actual distances are not the same everywhere on the planet. So, don't do it. Convert everything to projected coordinate systems and then do the analysis. Have I mentioned, never do analysis on a geographic coordinate system, on data in a geographic coordinate system. Always project the data first. Work in projected coordinate systems. Only do analysis in data in projected coordinate systems. I want to be clear. Only in projected coordinate systems. Never do analysis in data, on data, with data, for data, through data, or by data that is in a geographic coordinate system. And here's why. Distance joins in the coordinate systems. If you don't project the data will be distorted significantly from it being in a GCS. All projected coordinate systems distort some things, but they preserve others. And so if you're in a system that preserves distance, the distances will be correct. If you're in one that preserves position, then the positions will be correct. In this example, by going from a GCS to a UTM projected coordinate system, 3 of these attractions are now closer to a different hotel. A GCS, or a distorted projection, and by distorted projection we mean one that is ill-suited for the particular area. Think of using Virginia State Plain South in Northern Virginia, or better yet, think of using New Jersey State Plain for, I don't know, Montana, something like that. That's a severely distorted projection. Anyway, if you're in a GCS or a really, really bad choice of projections, it will monkey up your numbers. It'll make things not look right. It'll make things wrong. Beware, beware, beware. The data frame coordinate system may be different from the source data coordinate system. Setting the data frame coordinate system is not enough to fix the problem. You must project the source data using the project tool. If it's a raster, you got to use the project raster tool. That's as close to singing as you're going to get. The best thing and the worst thing that software like ArcGIS does is on-the-fly projection. On-the-fly projection takes data that's in a different coordinate system and displays it properly along with other data in different coordinate systems. But to do spatial analysis, everything should be in the same coordinate system. So do that. How do we set up spatial joins? This is probably where this will get confusing. Alright, sketch the layers. Do you want the output layer? How do you want the output to look? What's the destination? Is it going to be its distance? Is it going to be inside? What's the cardinality? Will it be simple? Will it be summarized? Here's how I do it. I always ask myself, what do I want to join to what? And then I start with wherever I want everything to end up. So if I want to add my county data to my city, I start with my city and join in my counties. If I want my city data to be joined to my counties, I start with my counties and I join in my cities. When you try to do these joins, you run into this idea of it's either simple or summarized, it's either distance or it's inside. It's only 4 options, and generally speaking, as soon as you select which thing you're joining what to, it really narrows you down to 2 options. Worst case scenario, you do it wrong once before you get it right. So the main thing is, and this is an important lesson for all GIS when you're starting out, you cannot be afraid to do things incorrectly. The only way you learn what doing things right looks like is by doing things wrong and recognizing that they're wrong, and then changing your approach until you get it right. It is far worse to get things wrong and not know that they're wrong. And if you don't know what the wrong join looks like because you never ever did one incorrectly, because all you ever did was follow the exact instructions perfectly until you got an answer and stopped, well, you're going to have some challenges if you think you're going to be a professional in this field. You have to be prepared to, on occasion, make a mistake. And as long as you have the skill set, the knowledge, and the gumption to investigate and recognize your mistakes and fix them, it's not really a bad thing. Some examples: all the congressional districts that have had more than 10 earthquake deaths. There they are. How do we do that? Well, we can look at these things and we can join them up and we can try to figure out what we're joining to what. And is it going to be simple? Is it going to be summarized? It's a mess to try to think and figure and work all this stuff out. What's the source? What's your destination? We've got all these earthquakes, and in this example, we're going to join points to the polygons, and so I guess we want each of these congressional districts in these states to have that earthquake deaths associated with them, and so if there's more than one in a particular district, it would be associated. So it's not a single thing. It's not going to be a one-to-one. It's going to be multiple things going to the other things, and because I ultimately want all this information to be joined to the districts, I would start with the districts, and to that I would join my earthquake data. Develop a population risk index for rivers based on the total number of people in the adjacent counties. How would you do something like this? Well, what do you want it to look like? How do you want to do it? Here we've chosen a layer to join to this layer or load spatial data from a disk. We're looking at the counties. What are we joining? Polygons to lines. We're going to select a feature class from above. That'll blah, blah, blah. Each one will be given the the summary. And you can see now how in each of these rivers, we now have the count, which is the number of counties, and we have the summarized values, which is the populations and other things. So now we can figure out how many people are in the counties that the rivers spatially intersect. Create a table showing the volcano closest to each city in the U.S. Alright. Same kind of scenario. You guys can work through the tutorials. You can, if you really want to see more about this when you're doing the tutorials, watch Dr. Maribeth Price's little video clips about this. See if you can figure it out.